Hello, in this video I will be discussing the lag lid filter and how it can reshape chip design in some ways. So here I have two images. The first one, the image on the right, is an image showing the lag lid filter. And the image on the right is another image. It's a different one, different graph slightly. That's also an image of the lag lid filter. So first, I will discuss what the lag lid filter is. So it's a device that it inserts like a pole and a zero, and it inserts this into like a loop function. The reason it does this is to change the response the system has on certain frequencies, because frequencies depend on how a device acts. It changes the behavior of the device. Uh, the way it's designed is that the pole usually has the lower frequency and the zero part has the higher frequency. The reason for this is because it makes the device more stable, the lag lid filter. The lag lid filter also helps, yeah, as discussed before, it makes devices more stable, and it also helps to lose less phase. And this is compared to standard, low pass filters. This device not just changes the behavior of a system in certain frequencies, but it helps to adapt to different frequency environments. It can adapt to a low frequency environment and then attenuate, change to a high frequency environment when that is needed. So here's a graph showing the lag led frequency graph. Here's the lag part, and there's the lead. This is how a device changes, how the behavior of a device changes due to the lag lid filter. Now I will discuss the lag lid filter's use in chip design. So, first of all, within chip design, the lag lid filter is used to help avoid errors in the design process, such as when the device isn't stable, a lag lid filter is used to make it more stable, the chip itself. Because it helps, the lag lid filter helps to adapt to various frequencies, as discussed before. And the reason this is important is because it helps chip designers, it allows chip designers to choose which bandwidth the loop should be. You see, if a standard filter was used, this wouldn't be so simple then, because then you'd have to, you see, the bandwidth that the loop is, it would have to be dependent on the filter. It'd get more complicated. But here, if you use the lag lid filter, you can, the engineers can choose which bandwidth the loop should be, and that makes the design process more simple and more enjoyable. It helps avoid errors that way. Another thing is that within this field of chip design, specifically here, chips that are designed for power and energy resources. So the lead part of the filter, it helps to increase the damping ratio. So there's this damping ratio helps increase it, and as a result, problems are prevented, such as overshooting, which helps them increase, helps reduce errors in chip design, specifically these power chips, and it helps to, make this design process easier. And just to mention, overshooting is when voltage or current goes above what is expected. So as you can see, here's a graph showing that voltage is expected to go not past this line. That's not that's the expectation, but the voltage goes above it exceeds what it's expected to go. And the third thing I will discuss is that the lag lid filter, it can also help reduce noise in chips. And if you check one of my previous videos, I discussed why noise is a problem in chip design. Essentially, it's a problem because you can't really always tell if the noise it's because there's a defect in the chip and that's why there's noise, or maybe it's just normal noise within the chip. And if it's a defect, then there's a problem within the design process, and that can lead to defective chips. You see, but the lag lid filter, it helps to reduce the noise within the chip, and this helps prevent those errors and prevents defects in chips. So that is about it for this video. Here are the sources that I used. And yes, so essentially to summarize, a lag lid filter, it's like a device that helps change systems, behavior to frequency. And it's used in the chip industry to, well, it's used for many reasons, but essentially it helps to make the design, the device, in this case the chip, more stable and avoid errors, specifically overshooting and going above, when either the voltage or the current goes above what's the expected, you know, limit. All right, that's it for this video. See you in the next video.